Talk on right triangle trigonometry. I love trigonometry. You guys will not, but I do. If you do not have a calculator, you will need one. I don't think you'll need it today. I don't think we're using them today. But you will need to learn how to use the sine, cosine, and tangent buttons on your calculator. Exactly. Trigonometry. Notice, I have calculators. You guys know that. Does somebody have one of my calculators, by the way?
I have a calculator that's the exact same.
Did you put it in the bin thing? I'm missing a calculator. Fantastic. Okay, if anybody sees one floating around, let me know.
I'll take it and keep it.
All right, so notice this says right triangle trigonometry because you can only use this with right triangles. Stop. We can only use this with right triangles. That's very important that you guys realize that.
Friday, I found it.
Really?
Nope.
Oh. Don't make me feel like I found my calculator, okay? That was rude. Okay, so what is this? So first of all, let's talk about this. What is the hypotenuse of triangle ABC? Helena. Hypotenuse is opposite the 90-degree angle. On the quiz tomorrow? No, the quiz is just 45, 45, 90, and 30, 60, 90.
Miss Brady is so patella.
Yep. Yep. I just want to cry because one of my calculators is missing.
Wait, he found it.
No, that was a joke. It's Greg's.
Sorry, Miss Brady.
He made me feel like I got my hopes up and then he just broke them. Name the side opposite angle A. What side is opposite angle A? A side needs 2 letters, please. Thank you, Hunter. What did you say? BC. If you look at this here, opposite angle A is the side of BC. What is the side opposite angle B? AC. Good job, Casey. Opposite angle B is AC. Name the side that is adjacent to angle A. So the side adjacent to angle A is AC. Adjacent to means next to. And it's not the hypotenuse. So the side that is next to angle A, but is not the hypotenuse. So the side that's next to angle A is AC. Do you see this? Which is not the hypotenuse. So what would be the side that's adjacent to angle B, Greg? BC. Okay. It's important you know these things. So is anybody confused by the words opposite or adjacent or hypotenuse? Because those are going to be words you need to know. No, this is not on your quiz. My other class is taking the quiz today before I even teach this. It's only 30, 60, 90s, and 45, 45, 90s tomorrow, okay?
Yeah.
No calc.
Yeah.
Tomorrow on the quiz. That's exactly what I just said, yes.
Couldn't understand you because
No
you were
doubt.
trying to use abbreviations.
Sorry. Okay, so what is trigonometry? What is trigonometry? Shh. Trigonometry is the branch of mathematics dealing with the relations of the sides and angles of triangles and with relevant functions of any angles. So, theta, this is theta, it's a Greek symbol. If theta is the measure of an acute angle of a right triangle, opposite is the measure of the leg opposite theta. So in this case, if this is theta, this is opposite. Adjacent is the measure of the leg next to theta that is not the hypotenuse. So you'll notice here, this is the adjacent because it is next to theta there. And the hypotenuse, not the hypothesis, I think that's what it says. So do you see how it's in red? Change that to hypotenuse, is the measure of the side opposite the right angle. Then the following statements are true. So let me just get hypotenuse up here real quick. You can change that to hypotenuse. Sorry. So, sine of theta is the side opposite of theta over the hypotenuse. Cosine of theta
Why is sin
that's
near
sine.
0? Oh, sine.
Okay,
near
good,
0.
good.
Why is that?
That's the theta symbol.
Oh wait, no, never mind. There it is. I see it on the
Sometimes you'll have to
triangle
start from C.
Okay,
Theta or beta?
theta.
Theta.
This symbol means theta. Okay, freeze. We aren't even confused with anything but how I'm saying things. So let me stop for a second. It's new words. Just stop. This is not sin. This is sine. Sine is the function. It's shortened to that. Okay. Freeze. Freeze. Stop. So I'm saying theta because theta is in angle A right now. Do you see how theta is marked in angle A? Theta is just like using the letter X. It's just different because you're not used to the Greek alphabet. It's okay. Theta is often used for angles. It's okay. Okay. There's other alphabets out there, people. Okay. So sine is opposite over hypotenuse. Cosine, this is cosine. Cos is short for cosine. Is adjacent over hypotenuse. Can you just stop, please? Guys, all of you, stop. I need to get through a lesson, and you are making it hard because you are just complaining this whole time. I have not even gotten to teaching any of this stuff yet. Stop. Okay, tan is short for tangent of theta, which is the angle A in this case, and that is opposite over adjacent. So you take the side opposite over the adjacent side. The cosecant, secant, and cotangent are the reciprocals of this. So the reciprocal of cosine is the cosecant. And that just means it's the flip of the sine. So you just flip the opposite and the hypotenuse. The secant is the flip of the cosine. So that means you just flip the adjacent and the hypotenuse. Just one second. And the cotangent is the flip of the tangent. So that's the adjacent over the opposite. What's up, Casey? This one here? This is cosecant. And then this one is secant. So how am I going to teach you guys how to even remember what these are in the first place? Because that is not something you're going to memorize. So there's a little trick, and we call it SOHCAHTOA. SOHCAHTOA. This is how you're going to remember these situations here.
Okay, so they're each just backwards of each other.
Yeah, so the flip of the cosine is the cosecant, the flip of the cosine is the secant, and then the flip of the tangent is the cotangent. So here's what this means. This S stands for sine is opposite over hypotenuse. So, do you see that O and the H there? Opposite over hypotenuse. The C stands for cosine, which is adjacent over hypotenuse. Good. And T is for tan, like Rob said, which is opposite over adjacent. Will you be able to remember that a little bit easier now? The only thing is to remember which ones are the flip of each other. The cotangent is pretty easy to know that it's the flip of the tangent because it literally has the word tangent in it, right? These two I think are confusing because this one starts with the letter C and this starts with the letter S. And this one starts with the letter C and this one starts with the letter S. Do you see how it's almost opposite of what you think it would be? So an S goes with a C, an S goes with a C. Do you see that? And then cotangent is pretty easy. So sine goes with a C, so it's cosecant, and that just means to flip it. S goes with a C here, so cosine goes with secant. That just means to flip. Cotangent is the flip of the tangent. Okay, so SOHCAHTOA, your new best friend, SOHCAHTOA, for the next couple weeks here. Or what, next week-ish. I'm going to write that up here so we don't forget.
Is the theta going to be like replaced with the over, or is it going to be like...
Not the first couple days, but later it will. All right, so, because we'll use it to find theta. So find the values of the 6 trigonometric functions for angle theta, which means that we're just finding the ratios. The values also are known as the ratios without solving. This does not mean to solve anything yet, because you guys don't know how to do that yet. So first of all, we need the third side. How can we find the third side?
I already have it, but I forgot.
Do you know the formula?
Yeah. Or a squared plus b squared.
So that is the Pythagorean theorem. So we're going to use a squared plus b squared equals c squared. So that's 8 squared plus 15 squared equals c squared. It is a triple, so if you notice that it was a triple, you should be able to just get the answer right away, but most people don't just memorize the triples, so, or most of you guys wouldn't. So C is 17. So we have all 3 sides. That's the first thing we need to do. Okay. Now we need to label opposite, adjacent, and hypotenuse. The easiest one to label first is the hypotenuse. So Desiree, which one is the hypotenuse? 15, 8, or 17? So this is my hypotenuse. Gabe, what is my opposite? No, it's never of the 90-degree angle. It's of theta. Could you see how there's theta inside here? So that forces the last one to be adjacent. So that's the first thing I would do is make sure you know what side is which. So the first thing it asks for is the ratio of the sine of theta. We know sine is opposite over hypotenuse. So Rob, if sine is opposite over hypotenuse, what number do we put in for opposite in this triangle here? Sine is opposite over hypotenuse. So which one is the opposite here? Huh? No. Opposite of theta. 8 over hypotenuse, which is? You're right. So that's opposite over hypotenuse for the sine. Okay, Kylie. The cosine is adjacent over hypotenuse. So what is my adjacent?
15.
So it would be 15 over?
17.
It's not solved. This is just writing the ratio. We'll talk about solving tomorrow. We're going to do this step by step so you guys can learn to write the ratios first. Because that, is part of it in itself. Casey, what's tangent then? What numbers would you do? Because it's tangent is TOA, which is opposite over adjacent.
You would do 8 over 15.
Trying to color code this too to make it visible for you what I'm doing here. Yeah.
It says COT on the bottom, but ours says 10.
Exactly, because that's why it's in red. It was fun.
Oh, so
We'll get to that in a second, don't worry. So these are already show you which ones are opposite each other, which ones are the reciprocals of each other. So sine and cosecant are reciprocals of each other, Greg. So what would the cosecant be then?
17 over 8.
17 over 8, because it's just the flip of that one. So it's 17 over 8. So the secant is the reciprocal of the cosine. So, Jill, what would that be then? And then, as Ian already pointed out, yours says tangent. Cross it off to make it say cotangent, because it should say cotangent there. That's why it's in red. So change your second tan to cotangent. And that is the reciprocal of the tangent, Lindsay. So what would that one be?
So for like the one that.
Yes, you just need to know which ones. You just need to know which ones are the flip. So sine goes with secant, cosine goes with cosecant, and tangent goes with cotangent. So those are just the flips of those. Okay? Does that help you to see that? Up there on the board, guys? To know which ones are the flips. I did that wrong. Sorry, that's cosecant, secant, cotangent. Sorry. So this is sine and cosecant are flips of each other. Cosine and secant are flips of each other, and tangent and cotangent are flips of each other. Or reciprocals is the correct math name for it. All right. So we have to do the Pythagorean theorem to find the third side of the next one. So a squared plus b squared equals c squared. Which variable are we going to be finding in this one? A or b, right? It doesn't matter which one you want to do. So I have a squared plus 2 squared equals 5 squared. We know the hypotenuse already. And we can't simplify the square root of 21, so this side here is just the square root of 21. So I start by labeling my hypotenuse first. So Cameron, which one is my hypotenuse? 5, 2, or square root of 21?
5.
Then I look for my opposite. Helena, which one's my opposite? Yes, always opposite the variable that's inside of the function. So do you see how theta is inside the function? So we're doing opposite theta. So that is opposite. And that forces the last one here to be adjacent then. Okay, so Devin, what is my ratio of the sine of this one? 2 over 5. Sine is opposite over hypotenuse, opposite over hypotenuse. Yes, Casey.
Okay, so is the opposite, is the adjacent always going to be on the bottom one?
No, because if theta was up here, this would be adjacent here. Okay, do you see that? So what I always do in the order I find it, I find the hypotenuse first because that's easy, it's the opposite, the 90, then I find the opposite. Because I think sometimes the adjacent is the hardest one to find. So if you already know the opposite and the hypotenuse, then you know the other one has to be the adjacent. Does that make sense? Okay, Morgan, the cosine for this one is square root of 21 over 5. Carmichael, what's the tangent?
2 over square root of 21.
Yeah, I have an issue with this one, though. He didn't do anything wrong. What is my issue? What do you guys think is wrong? Yeah, Jill, the radical is on the bottom. So what do I have to do?
So you have to divide it by 0.44.
You have to rationalize it. What do we have to multiply by? Square root of? You multiply by the radical in the denominator. So don't forget to rationalize that. So this is 2 root 21 over 21. I'm doing the shortcut there. Maybe you guys have finally picked up on that. I don't know. Yeah.
I thought it was Sokoto, so wouldn't that be opposite over hypotenuse?
Toa. Toe. Opposite over adjacent.
Oh, this is A. Oh.
Did my little line go away from you? Is that better?
I need to fix mine.
Sorry. All right. So, The cosecant here is what, Olivia? Oh my gosh. The secant is what, Daniel? What? Be careful. The secant is the opposite of the cosine, so flip this one. 5 over root 21. But can we have a root 21 in the denominator? Nope. So we rationalize. We multiply top and bottom by root 21. And that would just be 5 root 21 over 21. And then Hayden, I would reciprocate this one, not this one, because that would be a little bit more work. So what's the reciprocal of the tangent? Square root of 21 over 2. All right. Questions on writing those ratios? I don't have a lot of time with you guys. I want to see what you guys have here. Okay. Let's go on to the next page here. So these are 45, 45, 90s, and 30, 60, 90. So let's do the 30, 60, 90 one. I'll skip the 45, 45, 90 here. So I'm thinking angle theta is 60 for us in this one here. So if this is n root 3, if that is n root 3, we have 3 equals n root 3. So I have 3 root 3 over 3 is n. So that's just n is radical 3. So opposite the 30 is radical 3. And opposite the 90 is 2 radical 3. There's no way we're finishing these notes today. Yeah. So we're going to do it of the 60-degree angle. So I'm going to change this theta to 60. So what is sine of 60? What is sine of 60? Somebody tell me the sine of 60. So sine is opposite over hypotenuse. So let's focus on that first. I guess I should have you guys label that stuff first. What color have I been doing that in? Hypotenuse was purple. Okay, so which one is the hypotenuse here? Is it 2 root 3, 3, or root 3?
2 root 3.
It is 2 root 3. What side is my opposite? It's the 3, right? And then that forces the bottom to be my adjacent. Again, it's not always that way. Okay, so what is the sine of the 60-degree angle then? What is the sine, Emma, of the 60-degree angle here? So sine is opposite over hypotenuse. 3 over 2 root 3. Oh, we can't have a radical in the denominator, so what do we have to do? We have to rationalize. So that's 3 root 3 over 2 times 3. Gosh, this is going to be a lot of work here. So 3 root 3 over 6. Okay, I'm going to freeze because that's probably confusing you guys. So 3 times root 3 is 3 root 3, right? Over 2 root 3 times root 3. Root 3 times root 3 is the square root of 9, which is 3. So 2 times 3 is, that's where that all came from, okay? 3 goes into both of those, so this is technically root 3 over 2. So the cosine of 60. Lindsay, what's the cosine of 60? What do you notice about those root 3's, guys? You're going to simplify out, right? So that's 1 over 2. Okay, tangent of 60. What is my tangent of 60? Logan, what's the tangent of 60?
And radical 3.
Which in this case and for us is?
Opposite.
Well, yeah, but in this case it has a number on it. It is.
Oh.
So the number is?
Oh, 3.
3 over.
Radical 3.
So we have to rationalize that. So that's 3 radical 3 over 3. 3 divided by 3 is just radical 3 there. Okay, so then we do the flips of those. It's important that you're thinking about the flips in the easiest way possible. If I were to flip this one here, would I have a radical in the bottom? If I were to flip this one here, would I have a radical in the bottom?
No.
So does it make more sense to flip this one? Yes. So that would be 2 root 3 over 3. Okay. If I flip this one, am I going to be dealing with a radical? If I flip this one, will I be dealing with a radical? No. So secant is just 2 over 1, which is just 2. Does it make sense to flip 3 over radical 3 or radical 3? 3 over radical 3 because that's radical 3 over 3. Okay. Let me try to help you guys out with, let me see what we have here. Let's just do number 5 just to get you started on that, and then I'm going to get you guys the homework. You guys can ask me questions. We're going to be doing a lot with trig. I got to figure out where I need to go from here with you guys too. So whenever you're given the trig ratio, just draw a random triangle. I'm going to label the top angle theta this time. Label one of the angles theta. And you know this has to be opposite over adjacent, right? Isn't tangent opposite over adjacent? So opposite theta is 3. Adjacent to theta is 4. So we can now use the Pythagorean theorem to find the third side. So I drew a random triangle, okay? Just make sure it was the right triangle. Do you understand that? And I just chose theta to be one of these angles. So I just happened to choose this one because you keep on asking me about the adjacent being on the bottom, and I want you to see it's not always there. So you know the ratio for the tangent is opposite over adjacent by TOA, right? So that's why 3 has to be the opposite, and 4 has to be the adjacent. Does that make sense? Okay, and then I just use the Pythagorean theorem there. So for finding the cosine of that, what is the cosine then? What is the cosine here? Cosine is adjacent over hypotenuse. So what side is my adjacent? What side is my adjacent? What side here is adjacent? Next to that is 4 over the hypotenuse, which is? What's the hypotenuse in this one? 5. So let me get you guys your homework.